Hey guys, how's it going? It's Dilmer again and welcome back to my channel. So first of all, thank you very much for joining the channel. I really appreciate your time. And today I'm pretty excited because I'm actually going to be continuing the videos on shaders. And this time I'm going to show you something that I just barely learned, and that is how we can read information from audio files and then use that information to apply to our shader. I am creating a shader, and I created a shader where we're applying a noise, and that noise is basically creating a mesh in real time. It looks like a procedural shader, and what I'm going to be doing is applying the audio wave, the audio data that we're getting to the shader to apply deformations as the music plays. So let's jump into Unity and start working on it. Alright guys, so let me show you what we're going to be doing. I'm going to hit play and you're going to see the scene that I created for you. If I change the noise, you can kind of see that the shape is changing in real time. And that's because I'm using a shader, and I created this shader on the previous video. So what I'm going to be doing in this video is I want this noise, just the noise scale, be affected by basically music that we're going to be playing. I have audio files in here, and I'm going to be providing this project for you. So if I go into, for instance, one of these ones, and let me lower the volume. And what I want to do is synchronize the audio. So as that audio is playing, we're going to be playing basically the waves of what's called the spectrum in Unity. So I'm going to close that. And let me close out of iTunes. Perfect. So right now it's just basically playing, and this is not synchronized at all. So the first thing that we're going to be doing, that we're going to need, is we need some kind of manager that is going to allow us to retrieve what's called a spectrum data. And a spectrum data is basically a method that comes from the audio source. So I'm going to add that method here, basically a game object. And this one is going to be what I want to call the spectrum manager. And in the spectrum manager, I'm going to add a component. So I'm going to click on the component in the inspector of that, and then go into audio source. Once we have an audio source, we can simply select the audio that we want to add. We can select basically this one right here, Terminite Vortex. And I'm going to set it to loop. So if I hit play right now, we should be able to hear the audio, and it's very loud. So we'll fix that in a minute. All right, so now that we have that audio associated with it, we're going to need a script to do that, to basically read that information. So I'm going to add a component, new script, and this is going to be a spectrum manager. So let's hit enter, double click it. Excellent. So the other thing that I added to this project that I normally use in a lot of my projects is this folder called core, and all it has right now is just a singleton. And I like it a lot because it allows me to create a singleton with a generic. So we're going to be using this to create a singleton. The reason why I need a singleton is because I'm going to need to access this manager from the UI manager. So let's do that. Let's get that set up. And so now that we have the spectrum manager created, now let's just call mono behavior singleton. And the generic is basically going to be itself. Excellent. And it's going to complain that we don't have it, so we're just going to bring in the using statement, and that should set it up for us. So the next thing that I'm going to need in here is I'm going to need a couple of fields that are going to be serializable. So I'm just going to add my serializable attribute. This one is going to be a private audio source, and then it's just going to be audio source, and we're just going to set it to null by default. Excellent. So the next one is going to be a float of basically an array of floats. The reason why I need an array of floats is because the samples that we're going to get from the spectrum data, it's going to be in an array of floats. So normally you want to use basically powers of 2. So I'm going to get 512 samples. So we're going to set that, and we're also going to make it serializable because I want you to see how it looks when it gets serialized. So that's good. And the other thing that I'm going to need is I also need a property, because we're going to need to access these samples from the other class. So I'm just going to need a float property, and then we're just going to say samples, and we're just going to add our getter. and this is basically going to be get, and we're going to just say these.samples, and we're just going to return it. Excellent. Just align it, clean it up here. Perfect. And I think we're good there. So the next thing that I'm going to need is, I don't really need the start. That gets added by default. And we don't need this comment here. We know that this runs on every frame. So what I need to do now is I need to fill in the samples, which is going to be this array of floats. To do that, we're going to say Audio Source, GetSpectrumData. And then we're just going to say, okay, this is going to be the array that I want to get the samples from. It's going to be just channel 0. And then we're going to use what's called FFT window. And there's multiple options in here. And if we select this one, the one that I used in the past is basically this black man. So that's the one that we're going to be using. And perfect. And since this one is one line of code, let's just use some of the newer ways to declare the one-liner, which is using our lambda. Perfect. So we have our spectrum manager. So that should give us the data that we need. So now if we go back into Unity, I want to show you how that looks. So we're going to let the inspector get serialized. And we also need to associate the audio source with this audio source. Just going to associate it there. We could have done it differently. We could have said get component audio source. I normally like to do it this way because if I want to, for instance, put the audio source in another game object, I can easily just move it around. All right, so now that we have that, we can see the samples is now an array of 112. And they're all set to 0. So if I hit play, and I'm going to lower the volume. Let me actually mute the audio so we don't get that big, big sound coming out of the speakers. So you can see that now we're getting a big list of arrays. So what I want to do is, for now, I don't really need that many elements in the array. We're going to leave them in the array because I want to, at some point, add different graphs. So 512 might be overkill for what I want to do. I actually only need one of the elements, which is going to be element 0, to control this. And if you notice, the numbers are pretty low. So we're going to add what I call a multiplier, or you can also call it a scale number, where we're going to grab this number and multiply it by some other number to basically to scale it up and down, because it's way too low for what this takes. So the noise scale goes from 0 to 100, so we need basically to multiply that quite a bit to get to that number. So let's work on that piece next. Now that we have basically our samples getting back from the audio, we're going to go into our canvas and we're going to basically focus on the UI manager. Excellent. And now that we have that open, so there's a couple of things that I want to do in here, and that is I want to focus on reading the information from the update. So that's what we're going to do first. So the first thing that I'm going to do is I want to make sure that the deformation material is not null, because that's the material that is going to get the sample data. So that's the first thing that I'm going to do. I'm going to say if deformation material is not null. Then the other thing that I want to do is I want to add a new property on the top. This property is going to allow me to basically toggle if I want to use audio samples or if I want to just use the sliders. So for this, we're going to do a private bool, and then we can just say use samples from audio, something like that should work. And I'm just going to set it to false by default. And the other thing that I'm going to do is I'm going to make it serializable because I want to be able to control that through the inspector. Excellent. So then the next thing that we're going to need is we're definitely going to need the Singleton, which is the spectrum manager. But I want to create a reference in here because I don't want to have to do, right now if I want to access it, I could do a spectrum manager instance because that's a Singleton. And that's what the generic basically Singleton provides. And I can say, spectrum, and then I can say samples, and that will give us our samples. But I don't want to do that every time. So what I'm going to do is I'm just going to add a reference to it. So I'm just going to say spectrum manager, and by default we're just going to set it to null. This one we don't need to make it serializable because I don't need to associate it in the inspector. I just need this class to know about it. And then for this one we're just going to set it in the start. I'm just going to say spectrum manager, and then spectrum manager instance, and then basically just instance actually, because this is of that type. Excellent. So now that we have that, we can remove this comment. And the other thing that I want to do now is I want to check and make sure that the Spectrum Manager is basically the use samples from audio is set to true. So I'm just going to say if use samples from audio is equal to true, that means that we're going to be sending information to, getting information from the Spectrum and then sending them to the shader. Excellent. So now what we're going to do is we're going to calculate a value. I'm just going to say flow value equal Spectrum Manager samples. And this is basically our instance that we have right here. These are our samples. And like I was saying before, I don't need 512 on the array. I only need the first one, and because that's basically going to be enough for our example. And then we're going to also need a multiplier. For now, I'm just going to multiply by 1,000, but we need a new variable on the top that is going to allow us to change that. So to do that, I'm going to add a new variable. That one is going to be a float, and we're just going to call it sample multiplier, or you can call it a scale as well. And I'm just going to set it to have a default of 100. And we can replace that 1,000 with that number. Excellent. So another thing that I need to do is I'm going to get a clamp value. So I'm just going to say clamp value, because I only want to get numbers from within a range. So I'm just going to use math.clamp value from 0.1. The reason why I don't do 0 is because 0 is basically going to make the shape disappear. I don't want the shape to disappear. I want it to always see it. So you can parameterize these ones if you want. You can add variables if you want as well. I'm just going to do hard coding for now. I think that's perfect. So the next thing that I want to do is I don't want to execute these too frequently either, because if we execute it every frame, we're not going to get really good effects. I actually tested that, and it didn't look right. So we're going to add a little timer here that is going to allow us to basically execute it, either every second, every 2 seconds. So to do that, I'm also going to add another serializable field. That serializable field is going to be a private flow. We're just going to say delay by, and this is going to be if we want to delay by 1 second, 2 seconds, and so on. And then I'm also going to add a flow of the elapsed time that goes, as time goes by, I'm going to be adding to this variable. And this one doesn't need to be serializable because this is going to be just internal. This one we're going to allow people to change. We're going to be able to change it in real time, and we can see the changes on the shape. Perfect. So now let's go down here, and we're going to do basically our calculations for the timer. I'm just going to say if elapsed time is greater than or equal to delay by. That's when I'm going to be calling basically our changes here. So I'm just going to say if that is true, if we hit the max, meaning if it's 1 second, then I want to change the values. So in this one, I'm going to pass in the new value, which is going to be clamp value, and I'm also going to pass in the noise. For now, we're not going to use the time speed. I'm not going to be changing that value. So I'm going to comment it out, but I'm going to be changing the noise scale slider. So for that one, we're just going to say noise scale slider change, and we just call it directly, and we're just going to say clamp value. This one, I'm going to do another video where we can set this one as well. We can also change the color programmatically if we wanted to, based on the audio wave. So let's just focus on this one for now. I think that will give us enough insight to get you going on basically creating more. So right now, so if we haven't reached basically our max, I'm going to say elapsed time, and I'm going to sum that by the delta time times 1.0. And then the other thing that I've been doing is just put a log in here so that I can see that. Make sure that we can see what the elapsed time is. And lastly, we gotta set the elapsed time will go to 0 because I want to, once I change the noise, I want to start over basically and I start counting. Then once we hit the max again, then we do the noise scale slider change. Excellent. So that's all good. So now that we have these, so this is basically for audio waves. So if we're reading the audio information, we're changing the shader data. But I also want to be able to control it through a slider. I might not want to use these every time from the audio. So I'm going to do an else in here. and that else is going to be for the basically for our handlers. So if you remember on the start, and I didn't mention this, but on the start we have a couple of listeners that get executed. And the problem with this is if I change the slider, what's going to happen is this is going to get executed and everything else is going to execute it. And I think that's completely fine. I think now thinking about it, if we do use samples from audio, whenever this is set to true, it's going to get in from the audio. If it's not set to true, we're just going to be able to control it through the slider. So I think we're fine. We don't need to do an else. We can test it and see what we get. And then, in fact, I'm going to remove this comment as well. So I think all of this looks fine. Let me just give you an overview just to make sure that we have everything correct. So I have a use samples from audio, which we're going to be, just changing to true whenever we want to get samples from the audio files. We have our spectrum manager, which we creating here, that is getting us the spectrum data that is then filled into an array. Then we have two event handlers, that basically two listeners that are executing two events. And whenever we change the time speed slider, this is going to get executed. If we change the noise scale slider, this one is going to get executed. We can also remove this comment. Then on the update, what I'm going to be doing is if I have a deformation material assigned, which I do, then I'm also going to check to make sure that I have use samples from audio set to true. If this one is no, we're not going to do anything. If this one is set to false, we're also not going to do anything. But if we do want to get samples from the audio, I'm going to get the spectrum manager samples of the index 0, which is going to give us the spectrum data at index 0 in that array. And then we're going to multiply it by the multiplier that we declare above. Then we're going to get a clamp value between 0.1 and 100. Then we're going to start a timer. And if we hit basically the delay by, which is going to be our max, we're going to change the noise value directly, and then we're going to reset the elapsed time so that we can start over. Otherwise, we're basically incrementing elapsed time, and then we go through the loop one more time. So let's go and check it out and see if this is working. And what I'm going to do this time is I'm going to go to the spectrum manager. I'm going to click on mute audio because I want to listen to the audio, but I want to lower the volume because it's too high and it's going to be really hard to talk. Let's just do 0.5 and see what happens. And then hit play. And there we go. So we're not seeing anything because I haven't set that variable. So I can still, I can still make the changes here manually. I can change the speed. I can change all that manually. So let's go ahead and go into our sphere. And actually our canvas, that's where we have the UI manager. Let me go here and lower the volume a little bit more so you can hear, you can actually listen to me. And what I'm gonna do, you see the use samples from audio, and I don't see the multiplier. Let me just click on play to stop it. Looks like we didn't serialize the multiplier, which we're gonna need to serialize it. And we need to serialize that one. Okay, let's go back into Unity. Wait until that gets set. And I'm pretty sure we're gonna need about 1,000 at least. And we're going to, okay, so that's all good. Let's go back into our spectrum manager. Let me lower the volume to something like this so that you can hear me. And I'm gonna hit play. All right, so now that's good. So now let's go into our canvas. Let me collapse the rect transform so you can see what I'm doing here. And now if I hit use, you can see that I'm starting to get some of the samples on array index 0. In fact, if I go to a spectrum manager, you can see that I'm getting, that's the value that I'm getting, and then multiplying by 1,000. This is not pretty fun. I'm not seeing some crazy, some crazy shapes. So let's go, oh, actually now it's working good. So let's do something like every 0.1 second. So now we're starting to get more, it looks like it's more synchronized with the music. Let's go back to the spectrum manager, lower this a little bit more. There we go. Let's go to the canvas. And in fact, we could do 0.5 and see the difference. I really like this, working on this, because it really gives a dynamic look. What if we do 100? And we can see that's changing. Let's just do 1000 again. Let's do 0.2. And we can just watch it for a second. And it's really cool. You kind of see that as the waves, are hitting, as this number is going up, we're seeing some discrepancies, some changes on the shapes. What if we do 10,000? There we go. So that's really cool. The other thing that I can do, and you can actually do, because I'm going to be providing this project to you, is, let me go back to here, let me lower this a little bit more. So the other thing you can do is you can change the color. So if I wanted to do, you wanted to make some changes, you can go to the post-processing volume, look at the bloom, and then you can change the bloom value. We can do some retro, some kind of Tron-like colors, and that looks really cool. And you can, there's a lot of different settings in here that you can change that I already set for you, that you're more than welcome to play with. You can do the color grading, and if I wanted to change, make it more like old school or something like that, you can always, go in and change it. I'm gonna leave this one on 0, and there we go. So that's everything that I wanted to show you guys. So for now, I think I'll wrap it up, and I'll be pushing these to GitHub so that you can download it. Alright guys, thank you very much for watching, and I really appreciate your time. I also wanted to mention that I have a GitHub page, which is going to be where I'm putting this project that we just created in this video. Make sure that you check them out. You can basically download the source code, the project, and then use it for your own projects. It's completely open source. I also wanted to mention that I have a sponsor, and that sponsor is GameDev.net. They have amazing resources for game developers, a lot of information in their website. So make sure you check them out, and thank you very much for watching.